Hello. Now, this last shot is just giving us examples of how we can generate the formula of a compound from its name. I've read examples from binary compounds to oxoacids to quaternary compounds and so on like that. Now, let's look at the first example. I want to write the formula of nitrogen 1 oxide. Now, what you should know is that when it is nitrogen 1, the oxidation state of nitrogen atom is +1. And whenever you see oxide in a compound, it means O2 minus. Now, in order to ensure that a neutral compound is formed, what we simply do is that the number of positive ions must be equal to the number of the negative ions. So, what must be done, just like we did earlier when we were forming compounds, formation of compounds. Now, this positive charge has to be 2, so that it balances up with the two negative charges, and hence we are having N2O. Now, we say for there to be the balance of charges, two nitrogen atoms will combine with one oxygen atom. The two nitrogen atoms will create a 2 plus charge. Combining with one oxygen atom with 2 minus, that will give us 0. That means the compound has to be neutral. Now that's the first example. The second one now is talking about trioxosulfate 3 acid. The first thing you should know is that when anything is mentioned and the name is ending with acid, be specifically mineral acids, hydrogen must precede the compound. Hydrogen must precede the compound. So hydrogen is always having a charge of +1. It has been mentioned there that it is phosphate 3. So meaning that the phosphorus there is having oxidation state of +3. So phosphate 3 with phosphorus in +3 oxidation state, then your oxygen is O2 minus and you're having trioxo. So if you calculate the charges, what we always do is that combine the last two first, that is the P3 plus and the O2 minus. Now this is +3 and the net charge is going to give us -6. That's giving us a total of -3. That's +3 minus 6 is -3. So if we combine that now, we are having PO3 and the net charge is 3 minus, and hence you have 3 minus like you're having here. This. So you have PO3 3 minus. Now combining it with H plus, just like we explained earlier, there has to be balance of charges for us to form a neutral compound. HPO3 3 minus. Now H plus and you're having PO3 3 minus, the charges must be the same. So there has to be 3 positive charge to cancel out the 3 negative charge. Hence we are bringing in 3 of the hydrogen atoms to cancel out the 3 negative charges here, and that is giving us H3PO3. Now the third example, you're having calcium hydrogen trioxocarbonate 4, just like we explained earlier. Calcium is in group 2, hence the oxidation state is +2. Hydrogen +1, carbonate 4 has been mentioned here, meaning carbon is +4, and oxygen is -2. So if we bring all together, we deal with the hydrogen, carbon, and oxygen here being a quaternary compound. Hydrogen +1, carbon +4, oxygen -6, and the net is giving us -1. Meaning when we combine HC and O3, the charge on it is going to be minus. So now when we want to combine that with Ca2 plus, for there to be balance of charges, there has to be 2 negative charges. Hence we'll make the whole of our HCO3 to be 2, as in this. Now the next example is talking about chromium 3 tetrahydrosulfate 6. Chromium 3 Cr3 plus, sulfate 6 S6 plus, then you have O2 minus 4 tetraoxo plus 6 minus 8 here. That's minus 8 is coming from minus 2 times 4, and that is minus 8, and that is giving you -2. So you have SO4 2 minus combining with chromium 3 plus. For the charges to be balanced, 2 of these will make up to 6, while 3 of these also will make up to 6. So 6 minus and 6 plus. Hence we are having Cr2SO4 3. Now the last example there, we're asked to give the formula of monooxochlorate 1 acid. Monooxochlorate 1 acid. Just like I mentioned earlier, anywhere you say acid, the first element is hydrogen. So, having established that H plus, chlorate 1 tells you that should be Cl plus, 1 plus. Then your monoox, that tells you 1 oxygen, O2 minus. The net charge on that is going to give us plus 1 minus 2, that's minus 1. So you're having ClO minus combining with H plus. Since they are in ratio 1 to 1, there's no need of introducing any subscript. So the compound will simply combine to give HClO. Now you're having formulas here and you're asked to supply their names. This, I believe, should not be an issue because we have talked about this in our previous lessons. And I want you to please take a very good note, observe the name. Anywhere there's problem, we'll be ready to listen to you on our Google Classroom. Please, thank you for your time. Remain blessed while you watch again and again to gain mastery when it comes to naming of compounds. I remain yours, Fayomi J.A. Thank you and God bless.